Okay, go ahead. You can start now.
Okay, thank you very much. Welcome to this presentation. It's my specialization portfolio project. The 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 project is named Popchat. So it's an instant messaging application that allows users to communicate with each other via WebSocket connections. There are two types of chats on the platform. There are one-on-one chats that are direct chats between users, and then there are room chats where rooms are created and multiple users can be in a room. The app is made in such a way that there's universal access. If you know a user's username, you can always look them up on the chat and chat them up with that. So the team members are two, myself and Ron Collins. I worked exclusively solo on the front end, and both of us worked on the back end. Both of us are primarily back end oriented, but I know front end. So as for the technologies used, on the front end, we use Svelte because of its ease in manipulating component states and smaller bundle size. And we use the Socket.io client. Socket.io is an implementation of the WebSocket protocol, and it has a JavaScript client and a backend server. So on the backend, for our API, we use Fast API, which the API is divided into two parts: an authentication API, and a chat API. So the authentication API is HTTP based, while the chat API is Socket.io based. So it's an event-based API. So the database we are using, the primary database is MongoDB. We are using HTTP and WebSockets, and as a catch for user sessions, we are using Redis. We were planning on implementing a notification system with RabbitMQ. However, we were not able to implement that due to time constraint. And for deployment, we use Fabric for remote deployment, and also Docker to containerize our applications, and Docker Compose to spin up the applications. So for the architecture, we have a simplified architecture. This was not the initial architecture. The initial architecture was much more complex than this. However, we had to modify it due to time constraints. So on the back end, we have a web server, Nginx, which serves as our reverse proxy. And we have an API server running on a Docker container. UVCon is the application server that we are using. And it has an authentication API and a chat API, as I said earlier. So the auth API is written with Fast API, and chat API was using with the Socket.io server. So also our MongoDB is running on a container, on a Docker container, and the cache is running on another container, a Redis container. So it saves primarily the user sessions, and then the MongoDB contains the user info and the chat. So all these are hosted on a single EC2 instance on Amazon Web Service. So the propagation of data is such that the client, which was written with Socket.io client and Svelte, is hosted on Netlify. So the application, the client, once they log in, will send a login request, a normal HTTP request to the API server, and they are authenticated. Once they are authenticated, a token is returned, with which the client requests a WebSocket connection. And then if the token is validated, a WebSocket connection, a persistent WebSocket connection is generated. And that connection is established, through which messages are exchanged. So the project it was interesting. We were able to refresh a lot of things. We refreshed web hosting, design and implementation of REST APIs, and MongoDB, Nginx, and JSON Web Tokens. And then we're able to learn new technologies like Fast API Docker and Docker Compose, containerizing those applications, Amazon Web Service, and then Socket.io. So as I said, we had to scale down our initial architecture, and we still have some pending features to implement. So the successes we were able to achieve, we conceptualized the project, we made an architectural design, we were able to select the appropriate technologies for our use cases. We were flexible enough to adapt our initial architecture because of time constraints. We learned a lot of new technology and refreshed on others. We were able to successfully containerize and deploy the application, and then we hosted it on a domain that we bought ourselves. So challenges encounter time management. One, both team members are doctors working full-time jobs, and we weren't able to dedicate as much time as we would have loved to. And also project management aspects of the project, we were not able to manage project properly. So as we are learning new technologies on the way, there are, as we are learning also takes away some time. And then the initial architecture, as I said, is much bigger than this. So we had to scale it down. And then the initial features, we are not able to complement them. So lessons learned is that initial planning is paramount, because if you don't plan enough, you're modifying your plans and all that along the line to consume more time. Roadmap, very important. A project manager is actually necessary. So I would have suggested the project management program in ALX can pair some project managers with us during this period that will allow us to manage the project properly. Also, team selection is very important. You make sure that the components of the team members have the required expertise along the way. Automation is king. Work as a lazy programmer, you are smarter, you are able to automate a lot of things. Test-first approach is important. And next steps, there are some of these are already underway. So like making the website more responsive, testing, GitHub automations. Also, as I said, we will eventually implement the initial architecture. And also, we want to implement a notification system using RabbitMQ as our message queue and a notification library called EasyToast. And we also want to implement redundancy, because currently the system is not fault tolerant. There are not enough redundancies on the system. In conclusion, we're able to learn a great deal during this project, and we've gotten a firm grip of the new technologies, and also we're able to refresh on old ones, especially in the realm of deployments and web framework. So we're looking forward to refining the project and making it better in the future. Thank you for listening. And if time permits, I would like to show the initial architecture. Can I go ahead?
So I think you can show us the initial architecture quickly, and then we also need to see the demo, and then we need to have a question and answer. So please try to make it as quick as possible.
Yes, it will fast.
Okay.
Thank you. Okay, so yeah, this is the architecture that is currently being implemented. But initially, we had this architecture. We wanted to use a microservice architecture such that we have a notification service, we have an API service, and then we have a database and a cache service. So initially, the apps have the message queue was supposed to be on the as part of the architecture, in the sense that when a message is sent, we don't want to retain the message persistently, because the database one, we have limited resources. So we want it such a way that when a message enters to the API server, it is sent to a queue, that a consumer service will be running. So the consumer will consume the message, and then once the client reads the message, a request is sent through the WebSocket that notifies the app server that the user has read this message, and then the message is cleared. So that's the main difference. And then rather than containerizing,
Try to go through the architecture quickly because I also have other meetings to attend.
okay, so I think that's the major difference. And then the way the apps are containerized right now, we have the API container, we have the Redis container, and the MongoDB container. So the parts of the backend are simply separated into different containers, but the architecture that we'll be moving on later is having them in terms of services rather than like segregating each part of the app. I think that's all. That's all. Thank you very much for listening.
Okay, great. Can we see the demo?
Yes, bringing it up. Is it the initial demo that the video that was recorded, or I should do the demo all over?
Yeah, if you can, like, let's just see the features quickly.
Okay, great. So the app is deployed on a website in this domain, popchat.dromkojin.com. So this is the initial page for you to log in. To simulate a second user, I will open the same website on a different browser. So we have some users created already, but so as to showcase the registration process, I'm going to the registration site. So I will create a new user called test user.
I think it's okay if you don't, if you have a user which is
Okay, I
already.
can just log in. Okay, so I'm logging with the user now.
Okay.
So I'm logged in as the test user 21. So for a second user, I will log in a separate account. Okay, so these are the charts. So I've started a chat with test user 21 already. So the last, when a chat is clicked, the layout is simple. You have all the active chats on the left, and then you have the chat window on the right. So the search bar can either filter, for example, if I want to know the chat that starts with test, so I can filter it. So it will automatically filter the chat and give you what the matches. And also, I can search other users that exist on the system by pressing @ and then putting the user's username. So for example, I start typing. So there's a user that matches that. If I enter this, so these are other users that I can chat on. So when I click them, their details pops up and I can enter, I can start chatting with them by clicking this message icon. So I can reply this message, for example, hello. So that's done, but I want to simulate with test user 21. So currently, hello there is the last message sent by test user 21. So as you can see, this is starting with this user. So this message was sent by Nasser. This is the current user. So if you look at it from here, it's starting with Nasser. Nasser, hello, there is the last message. So if I sent a new message from here, good morning. So if I do that, the message is sent. Then if you go to here, you see the new message bubbles up the chat, and then you can say, so when you open it, you reply. I. So the message is sent, and then here you can see, okay, it looks like a network. Sorry, let me refresh. Okay, sorry, I think that was a network each. So yeah, the message is there. So let me send another one. Yeah, so it's there now. So yeah, that was the network each.
Thank you
So
very much.
the other feature that I want to quickly showcase is creating a new room. So if I create a new room, I can add multiple users there. So let's say I'm adding test user 21. And then I'm also adding another user that I know exists, Rashid. If I create the room, a new room is created. You can view the room details, edit the room name from here. So let's say new room 45, save that. So that's reflected here. Then you can, because I'm the admin, I can text other users right from here. I can remove users from the room. So you see, test user 21 has been added to the room. So the room is showing up here. And
Yes.
then I can delete the user. So if I delete the user is removed from the room. If I send the text to the room, for example, the user, see it's gone from the list of chat because this user has been removed. Also, I can add the user back if I want. So test user 21, add to the room. So the user has been added to the room. It's back in the list of chat, and the user can view and reply messages to the room. So
Okay, Nasir.
yeah,
Thank you very
that,
much for
that's all.
presenting.
Thank you. Yeah.
Um, yeah, I would like to say this is a very good project. I think you have done a very impressive job starting from the architecture, uh, how the UI is implemented, how the chat works using Socket. So I think it's very great job that you did. Um, one thing I would like to ask you is how, yeah, so just a quick question on the backend. How did you structure your messages and how are you filtering them whenever someone um, sees this message chat?
Okay, great. So the message structure, on the back end, we mainly have um, three models.
Okay.
So we have the user model because we are using an ORM, the Mongo engine as our ORM. So the user objects are Mongo engine objects. So we have a class for the user, a class for chats, a class for rooms. So messages are embedded documents under chats and rooms. They're embedded in chats and rooms rather than being separate objects. So the structure of the message, can I bring up a board where I can type?
I don't think we can do that.
Okay.
We are
So
already at this time.
anyways, each message has three properties. So they are saved as a dictionary. So
Mhm,
the first one is the text, that's the content of the message. The
mhm.
sender, which will be the username of the sender. Usernames are unique in the system. Username is unique. Email is also unique. So each message has a text, that's the content, the sender, which is the username of whoever sent the message, and then the time that the message was sent. So since the messages are embedded in each room, so it belongs to the room, there's no need to do any linking like a relational database because we are using MongoDB. It's a document database. So that's the basic structure. A user object basically has a username and email, the password, which is the hash, not the plain text, the hashed password. and then a reset token attribute that we added when it will be used when we are implementing the reset password feature or any form of user updating and modification data. But for now, it's not in use. So for chats, one-on-one chat has the following properties. That's a name, no, not a name, user 1 and user 2, which are the users participating in the direct chat. The messages, a messages object that contains all the messages of the user. And then for rooms have the similar things as a name. A room has a name, as a members object that contains the usernames or a list of the usernames of the members. It has a messages object that contains the list of messages for that room. Then it has an admins object, which is the list of admins of the room, because you can have more than one admin. So those are the main objects that we have in the system. And then the messages in the database, we didn't bother to arrange the messages in chronological order. The chat API, one of the functions there is that anytime a room is requested from the front end, it will automatically rearrange those. It will rearrange the messages in chronological order so that they are displayed in the order in which they are sent.
I see.
So
That's great.
Yeah, thank you.
Yeah, thank you, Nasir. That sounds very great. Thank you very much for presenting. I also have to jump to other meetings now. And yeah, that sounds a very nice project. I have enjoyed seeing it, and also considering the technical parts that you have discussed. It was very interesting. Thank you very much for presenting, and I wish you all the best in your future career.
Thank you very much.
Have a nice
Please,
day.
I have a question. I think I sent you a message on Slack. Please kindly check it. Our pitch was not reviewed completely. So I sent you some messages. Please just check your check Slack. I sent you a private message, please.
Okay, I'll try to do that after a few minutes. Okay.
Thank you very much.
Okay. Thank you. Have a nice day.
You too.